The Big Bang was not an explosion in space. Time itself began with the Big Bang. Physics cannot describe before time began. Some theories predict a universe before ours. This question tests the limits of science. The Big Bang theory describes the early evolution of the universe from an extremely hot, dense state about 13.8 billion years ago. Importantly, it does not describe the absolute beginning of existence. According to modern cosmology, the Big Bang marks the beginning of space and time as we measure them. This conclusion arises from Einstein's general theory of relativity, where space and time are part of a single structure, called spacetime. When physicists mathematically extrapolate the expansion of the universe backward, they reach a state of infinite density and temperature, known as a singularity. At this point, equations predict physical quantities diverging to infinity, which signals the breakdown of known physics. Because time itself is defined by spacetime, asking what happened before the Big Bang may be similar to asking what is north of the North Pole. Within classical relativity, the question has no physical meaning. However, theoretical physics explores alternatives. One major proposal is cosmic inflation. Observations of the cosmic microwave background show temperature fluctuations at the level of only 1 part in 100,000, supporting rapid early expansion. Some inflation models suggest our universe as one region within a much larger, possibly eternal framework. Another hypothesis is the Big Bounce. In this model, the universe undergoes cycles of contraction and expansion. Instead of a singular beginning, a previous universe collapsed to extremely high density and rebounded due to quantum effects. Loop quantum gravity calculations indicate that spacetime may resist infinite compression at densities near 10 to the power of 96 kg per cubic meter, close to the Planck density. There is also the quantum vacuum model. In quantum field theory, empty space is not truly empty. Even in a perfect vacuum, virtual particles constantly appear and disappear. The energy of empty space is estimated to be around 10 to the power of 9 joules per cubic meter, which may have driven early cosmic expansion. Another concept is the multiverse. Some inflationary theories predict that universes continuously form, each with potentially different physical constants. While mathematically consistent, the multiverse currently lacks direct experimental evidence. Crucially, no existing observation can probe earlier than 10 to the power of 4 cubed seconds after the Big Bang, known as the Planck time. Before this limit, quantum gravity effects dominate, and no tested theory exists. In summary, science does not yet know what existed before the Big Bang. The Big Bang represents the earliest boundary of testable physics, not necessarily the beginning of everything. The question remains open, because it lies at the edge of human knowledge.